Can you see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Is it visible?
Yes, sir.
Yes, sir.
Okay. Okay. In my last class, it was an introduction to the course, and what I considered is how to switch from procedure-oriented programming to object-oriented programming, because you are all familiar with C. So what we to summarize, what we found is this procedure-oriented design, it suffers from these limitations, that the cohesion of between data and procedures, if they are related, that cannot be included in a single construct, and as a result, the total reusability of code, you cannot reuse the whole code, or I mean, you can, the reuse is restricted only to the methods or functions. There is also less control over data. So these are the problems, and in a real life scenario, if as a programmer we try to perceive the things, or any kind of computational scenario also, so the way you perceive and the way I perceive might differ, but we always try to identify the items which are important in the application and try to model them in our program, right? And how many items do I identify, to what level I distinguish between the components of the item, that entirely depends on the skill of that particular designer, or because once you have the design, you come up with the program. Okay, so what we found as no matter what uh, items we identify, any item or entity that we identify can have can be described in terms of its features and as well as its capabilities, and the features can be modeled by a programmer or in our program through attributes, or to be specific by writing variables or matrices, whatever, and the capabilities can be modeled or implemented using methods or functions or subroutines, whatever you say. So the program or the language must also have the support so that both of these two can be included, or can be integrated in a single construct. And we also found that all the similar type of items, those who are having similar capabilities, can be grouped into a particular category called class, and a class definition will have both those variables as well as the functions, and those variables and functions can be can be tagged with some uh, access specifiers. It can be tagged as private or public, depending on whether I am willing to provide access to those members, because everything that is included within the class definition are members. Whether I am willing to provide the access to the members to outside outside my structure, outside my class. If it is that, I make it public. If it is not, I make it private. And there is another protected we can ignore for the time being. And the relationship between uh, the classes, as we found, strictly there are two type of relationships, ISA and HAZA, and that also need to be modeled. And what we found is, using composition and using inheritance, these two can be modeled, and this process of putting together is called encapsulation, access specifiers, and those items, the I mean, every time we are talking about items, so those items are better termed in object oriented terminology as objects. Okay, so this much we have already done. So in this class, the focus will be to continue further, and we'll be talking about another very important characteristics of object oriented languages, that is, they can model polymorphism. So what polymorphism is, we'll try to have a very basic flavor of that, and then we'll switch to, so then we'll try to summarize the advantages of object oriented design or object-oriented languages, and we'll switch to C++ because we'll use C++ as a language. So with some basic introduction to C++, if time permits, I'll write the first C++ code. Okay, so that is a basic idea. So now so we talked about inheritance composition, we talked about class objects, access specifiers. Now let's see if I say I write, I think it is visible, right?
Yes, sir. Yes, sir.
Okay. So if I write int xy z, I can write x equals to y plus z. If I write float f1, f2, f3, I can write f1 equals to f2 plus f3. And if I write, so this is possible. Uh, just a minute. So the thing is, in this case, this is the case, or if I write something like this, say sum y comma z, I assign the value to x, and I write sum f2 comma f3, I assign it to f1, and then I write something like sum m1 comma m2, I assign it to m3, and maybe I declare m1, m2, m3 as something like matrix. Okay, if I write only this much, maybe I write everything within the main. So this is the main function. So first of all, if I consider this to be purely C, a C language code, so do you think whatever we have written will be allowed?
No, sir.
Which part will create problems?
So
So the
because
sum
some function is defined as
not
per
defined.
A bit louder because I cannot hear it clearly.
Sir, if some function is to be defined, then it should be of a particular data type. For example, it can be of int, not both. So it will be ambiguous.
No, I just have, so in this case, the thing is how many functions I am calling here. So here this sum and this sum. So how many functions I am calling? I am just calling one function.
And
Now in C the basic restriction is two functions cannot bear the same name, right? In C, can we have two functions having the same function name? Is it possible?
no, sir.
No, sir.
No, sir.
It is not possible. So those who have done C, forget about C++ or Java. In C, function names must be unique. That's the basic requirement, right? So this is not allowed because you see you are trying to have some function which will trivially add two integer values and it will return the sum, and another function also I would like to use the function name as sum, where I would like to add two floating point values I would like to return. So the internals of the functions are trivial, but we would like to see that whether it is allowed or not. So if I consider C, this is not allowed. So in C, what we need to do? So probably I would like sum int y comma z, and here I would probably write sum float f2 comma f3. If it is a C compiler, if I would have written sum underscore int and sum underscore float, will that be allowed?
Yes, sir.
Now you have got two distinct function names. The function names are different, and whatever you are doing, it is your business. So the compiler will allow it. And if I try to do something like this in C compiler, so this is not allowed. But in C++, the point is uh, multiple functions or more than one functions can have the same function names. Okay, so definitely I have to write some piece of code for this, that I'll do. But the thing is, these two, if I use a C++ compiler, will it be allowed? This is definitely not allowed in pure C compiler, but if I use a C++ compiler, will this be allowed to have
Yes, sir.
two functions doing something
Yes, sir.
different but having the same function name?
Yes, sir. Yes, sir.
Those who are not used to C++ or Java, any kind of object oriented programming, this might seem something strange, right? Because you say that how can these two functions bear the same name, but you see there is a subtle difference. So this sum is accepting two integers and this sum is accepting two floating point values. So the thing is, who should be able to distinguish, and how to distinguish this? So definitely visibly there is no difference because both the function names are same. And who is going to create the distinction? Can you just tell me?
Type of
The
parameters.
type of argument and
Sir,
type
the parameter list
One
and the return
because
type.
can any one of you speak a bit louder and tell me what do you say?
The type
of parameter
type of
and the type
Hmm.
and the type
But
of
type
return.
is fine, but when you compile this, who is going to take care? So if so the compiler compiles one by one the lines. When it comes to this line, so definitely to support this I should have a sum, say int a, int b, int, and then I write return a plus b. Is that fine? So this I would expect that when I call this, this copy should be uh, linked, right? And corresponding to this function, this sum, I would like to have something like float, say maybe p, float q, right? So I would expect that whenever the compiler compiles this, I expect this copy of sum should be, this body should be executed. Is that fine? Both the functions are having the same name, but they differ in the arguments that they accept. So if I write these two functions, what I expect from the compiler, when the compiler comes here, it should actually give a call to this function, and when it compiles this one, this should be a some kind of notation which will take the control to this function. Is that fine? So how to make this happen? That the point is this need to be done, and we accept, or I say that C++ compiler allows this. So how do you, what do you think that how the compiler can allow such things to happen? I mean, how it will handle the kind of this level of transparency or abstractness? Are you getting my question?
Yes, sir. Sir, they just, sir, when they see that there are two float values, they identify float sum and then return. Is that what happens? Like
Yes.
they
So the see
match
the
the
simple thing is,
signatures.
what the compiler does. The compiler decorates the function names. So you wrote for your so whose convenience it is? It is your convenience, because you know it's basically I am trying to add two variables no matter what their data type is, right? So you prefer to use the same name sum and sum. But what the compiler will do, when the during compilation, when the compiler finds that there are multiple copies with the same name, it will decorate this sum. Okay, let me use some different colors, some other color, maybe this one. So it will decorate it as sum underscore int underscore int. Okay, and then int like this. So this sum, this function name should be decorated, or it will rename this function as this, and it will rename this function as sum float underscore float and do the rest of it. Got the point? So this is the additional, something that the compiler does in the back end. And this also, there is no point now. Once this is translated, so this sum never remains like this, so it will translate it to this, and this also will be translated to sum underscore float underscore float. Now if the compiler translates this, now is there any ambiguity that remains?
No, sir.
No,
So
sir.
this thing happens actually. So when the C compiler compiler, so designer of C++, Brown Strausstrup, so when he implemented, he thought of something like this. Now based on the implementation, because we cannot see this, so like how this decoration is done, whether it is, so this is just one scheme that the compiler can follow. So this is actually done. So if you are able to, or somehow you can stop at some point while this takes place, you will find that there is no such ambiguity, because the compiler has already actually renamed the functions with the same name but which differs with arguments. So you can basically rename the function by tagging with the argument names in some form and make a distinction. So once this happens, then uh, as a result, what happens, like when you look into the uncompiled code, we find that there may be multiple functions bearing the same name, but definitely there must be some distinction in the number and the type of the arguments that they accept. So this particular feature of object oriented languages is known as, what it is called?
Function overloading.
Okay, so this is called function overloading. Now why is the term overloading called? So sometimes you see, I mean, generally, say if I look into the HOD's tasks, so our department HOD, what she does, she need to take classes. So she's basically a faculty, right? So her primary task is to take classes. That's why she took the job, and she likes teaching. So that is the reason. But once she's assigned the post of HOD, she's supposed to handle the administrative load also, right? So now what she says, that I'm now overloaded. So why overloaded? Because there is a primary task, but she's assigned some additional tasks, and she's now overloaded. So the thing is, now when she's in the class, what she does, when she's in the class taking a lecture, what role she's playing? As a teacher. So she just keeps teaching. When she enters her office, she just behaves like a HOD. Okay, so signs papers and all this, like that. At the same person, when she comes home, she plays the role of a normal person, a housewife, or whatever. What the point? So the same person, in this case the same function, acts differently depending on what we can call it as, the same function acts differently depending on what? Depending on
Depending on the situation.
The
What is
parameters
the
first.
situation?
depending on the context. So the context is a very common term used in a computational uh, terminology also. So it's depending on the context. So the context changes, your behavior changes, or I mean your action changes. So here also the same thing, the sum, if you pass two integers, it will trigger this, and it will just add two integers. If you call sum with two floats, it will call this value. So like that. So the same person, if you put it in the HOD's office, she will behave like HOD. If you put the same person in a lecture hall, she will start delivering lectures, like that. So depending on the context, that changes. So this is what is called overloading, and is also sometimes known as sorry. So this is also known as, can you see, this is known as polymorphism. Okay, so why polymorphism? Poly means multiple, and multiple shapes of whatever, so the same name. But we know that what is the advantage in implementing this function overloading? Who is benefited out of it? Who is benefited?
User.
The programmer.
User means, if I am reading your code, or if I am the designer, I am the programmer, So I don't have to really keep track and scratch my head to find out what should be the name which should be meaningful, function name meaningful, but also different from the one that I gave last time, like that. So you don't have to worry about finding out unique function names that will semantically sound similar but will do something different. So this is the, and if I read your code, okay, so I also will be happy because I will find that okay, it's sum means I know it's they are basically adding something or combining something. This is what sum means. Got the point? So this is a feature, uh, and you can see that in the real world also some it is not a modeling feature, but it is some kind of feature that provides abstraction to the code of what we see, and the readability also gets increased. And the thing is, in real life such things really happen, as I mentioned, and each one of us play multiple roles, multiple way, behaves in a different way depending on the situation or the context. So those are defined sometimes. Now the thing is, what we did here is we are trying to see that how the sum or the same function name works with what this int and float is. These are all what is int and what is float. What are
Inbuilt
these?
data types.
These are inbuilt data types. And what about this one, matrix?
It's a user defined data type.
So definitely matrix, there is no data type matrix which you have found in C, right? There is no such things. And in C++ also there is no such things. Let us assume that we don't have any kind of specific or special libraries or templates or whatever. Okay, so make things simple. So in the standard C++, in the standard C, there is no such data type which is known as matrix. But we know that we can create a matrix in uh, in C++ or in C. Now, what about this last statement or this last one? So this sum m1 plus m2. So will this be allowed? First of all, will this be allowed that you use the same function name sum to add to matrices also? Will that be allowed?
Yes, sir, if you define.
Yes. Yes,
Will
sir.
that be allowed?
Yes, sir.
Yes, sir.
So if I would
Yes.
like to have it, so what do I need to do? I have to write some piece of code. Okay. So now, so probably I have to write another sum because I just write the same sum and I just assume that the compiler will take care of the creating distinctions by decorating the names and all this. So I don't care. So then matrix m1 or matrix say x and matrix y, and here I write whatever it is. So here I have to write basically two for loops and all these details should be there. But then again, I mean, where should I write this body of the function? All those details I'm not getting into. So that we'll see later on, the syntax and all this. So the point is this function overloading, that is using the same function name to perform more or less similar activities with different with a difference in the types of arguments that it takes. It can work, or we can consider it for inbuilt data types and also for uh, user defined data types. Here matrix is a user defined data types. Hopefully somebody has written a matrix class, because in C++ or in object oriented language, as I mentioned, so you should be, you are expected to put the required methods along with the related data together in a single construct. So here probably earlier only there is a function, I mean there is something like this class matrix, and where you have actually defined I mean declared the uh, say a two-dimensional array, say maybe 10 comma 10, and then you have written some number of row size, then column size. Okay, so these are the features of the matrix class, features or characteristics. And then you have written something uh, like matrix initial, so you have to initialize, you have to write an initialization function. Okay, and you have to write maybe some display function, Okay, all the details of the display. Then probably you write some sum function. Okay, so the details of the sum, and you basically put everything together in the same construct. You see, so here this means this class matrix. So these are the set of methods. Again, don't just try to follow the syntax, because syntax I'm a lot of things just to put you into just express the idea. So these are the characteristics, and these are the methods or capabilities that the matrix any matrix object can do. So this I have done. So here maybe within this you have to write the body of the sum function. So if you have written that, then this also would have worked. Okay, that's the case. So here I mean, so now once this is there, assuming that this is there, if I write matrix m1 m2 m3, so what are these m1 m2 m3? What is m1, what is m2, what is m3?
Sir, objects.
So now you could have called it as variable, because it very much is what is this xyz then? What is xyz? What is x, y and z?
Variables.
Variables.
Variables,
Hmm?
sir. Variables.
Okay, so you still prefer to call it as variable, right? But probably if you are using C++, you see syntactically, so this is more of a C++ like code. So if you are really inclined to C++, and if you know that it is a object oriented language I am using, so you should better not call it as a variable. You should prefer calling it as object, because as variable is an instance of a data type. Here this class I mean this object is an instance of what? Object
Class.
is the instance of
Class.
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 And
Class.
can you recall, I mean, so do you accept it as an encapsulation? You are encapsulating methods as well as, so you have got a bag where you can put methods, and you can add the variables also. So the process of binding or putting them together is basically known as encapsulation. So this encapsulation is supported, right? You can have multiple just methods, the body, the function bodies, and you can have those these variables, those are characteristics you can bind. So this is what encapsulation means. Okay, so there is a more generic term that we use while talking about encapsulation. What is that? Can you recall? Data structure class we have encountered the term. What is that? Have you heard about ADT?
Yes, sir.
ADT. What is ADT?
An
Abstract
abstract
data type.
data type.
Abstract
Abstract
data
data
type.
type, right? So can you find any analogy with ADT and class? What ADT?
Yes,
What is
sir.
if I say that stack is a abstract data type, right? What does it mean? That means
So,
you have, so write the write stack as a abstract data type. So what you should have written? You should have mentioned the one dimensional array. You should have mentioned the integer top. You should have
So
mentioned
the
the size of the stack, and then you should have
functions.
also included the push pop display
Yes.
everything there, right? So together it becomes a abstract data type. Can you recall?
Yes, sir.
Hello.
Yes, sir.
So now you find that that abstract data type in C, is there any way of implementing abstract data type? Although the concept was there while we studied data structure, have you ever been able to implement abstract data type in C language?
Yes.
You are writing a stack, you are trying to define the stack data structure, but can you really put the push, the pop, the one dimensional array, the top, everything together? Is that possible in C?
So
It is not
encapsulation is
possible.
not
no,
possible.
sir.
Is not possible.
Separate
So
functions.
in true sense, abstract data type, although it is very much, you're trying to define a cohesive, come up with a cohesive definition, but that concept cannot be implemented in C. So that's why you don't have the facility. So you just told, okay, fine. So what to do? I just leave the function scattered as well as the data structure scattered. So all because there is no way of putting them together. Now in C++ or in any object oriented language, it has got this feature of encapsulation, where you can truly use it to implement the ADT. And once you have done that, you should from now on prefer to call an instance of ADT, or so ADT is a generic term. You can say that in object oriented terminology or in the language terminology, we call it as a class. So everything you can think of, that everything is a class. So integer is also, in this case, because it is C++, you can say it's an integer class, it's a float class. Instead of data type, you say it's an abstract data type kind of. So if you have used that term, so this instance of a class should be better known as object instead of calling it as variable. Okay, so I say that int x. So now you say that this is a integer class, and this x is a object of the integer class, right? Although I know that after all, yeah, it is that same variable, but we'll be preferring to use the different terminologies from now on. Up to this, is it fine?
Yes, sir.
Yes, sir.
Okay, so we are gradually trying to switch from from procedure oriented concepts, the beliefs that we have. Gradually we are trying to take one by one the steps towards the new paradigm. And because and why you use C++, because it is compatible syntactically, and also there are many things overlapping, so that it becomes much easier for a programmer to uh, switch from here to here. And in fact, the designer of C++, I mean, who designed C++, Strauss-Trup, also designed in that way, because as if it is an extension of C. That's why the plus plus is used. I mean, he used a nice name to know what it means actually, right? So this is one thing, what we call it as function overloading. The other part of the story is something like this. As you can see here, see what is this? What is this?
Operator.
This is an operator, right? This is a binary operator. So this binary operator, what it is capable of doing? This binary operator, now it is capable of adding to integers. But here what it does? It is capable of adding to floating point variables, right? Now if I write something like this, what does it mean? So this is again the same binary operator. Here it adds to integers and returns a value. Here it adds to floating point variables and adds. And here what I am supposed to do? I mean, what the machine is supposed to do?
Add complex.
So what is this complex? Is there any such complex, any such class or such data type known as complex that is already there in C++ or C?
No, sir.
No,
It is
sir.
not there.
No, sir.
So probably like matrix, you have to yourself write it for your convenience, right? So if you have written that, now you say that, okay, because these are just like a complex number, integer, float, these are all like values. So I would like to have the same readability to write this. Instead of writing, say, sum C2 comma C3 equals to C1. So this would have also worked fine, but I would like to have this instead of this. So definitely, as you can see, this is much better. This is a better choice than this, because whenever somebody reads, definitely the logic of adding to complex numbers and logic of adding to integers are different, because in complex numbers you add the real part and the imaginary part separately and then you store it. But again, readability of the program increases if I do this. So here again, there is some kind of polymorphic codes we are trying to enforce. What is that? Who is getting overloaded here? Earlier the function name got overloaded, right? The sum, the same name is called and it is acting differently, either this or this or this. depending on the arguments that you are passing. And here in this example or in this case, who is getting overloaded?
Operator
The can
overloading.
Sorry,
Operator.
the operator, specifically the binary operator. So you are trying to see the binary operator. It was already adding, it was capable and it was responsible for adding integers, float, character, maybe something else also. Okay, the long int and all this. Now you say that I overburden it, I add one more responsibility. So now he says that I'm really overburdened, so don't overload me. So and you keep on overloading. So in C++ or in any object oriented language, this is another feature that becomes handy. So the operator starts complaining, but you become happy because your code becomes more compact, more readable, and more understandable to you also and to whoever. If I see the code, I can instantly, and you really don't have to search for a suitable name, because symbols carry more much compact meaning, uh, you know compared to words. So like that. So here the problem is, so instead of doing this, I basically prefer to do this. And this addition operator, so this also would have worked. If this is the case, then you say that why not this will work. So if I write m1 equals to m2 plus m3, can this work? So somebody, if he's already sustaining some pressure, you say that let me put some more pressure onto it. So now this addition operator, we can make some provisions so that so if you pass, or if you have two matrix object arguments, these are matrix objects m1 m2. So if these matrix objects arguments are there, it knows how to add them also, definitely using two for loops. But I mean, that you have to write what exactly you have to do, but this can be done, right? So what we can call it as then, so this is definitely, this is also an example of overloading. And what kind of overloading I should call it? Earlier the function name is getting overloaded, so it is function overloading. And in this example, who is getting overloaded?
Operator.
Operator
Operator. So this is
overloading.
operator overloading. And what is the operator? It is basically a symbol, right? So operator is basically a symbol. And every language, no matter what it is, C, C++, Java, or whatever, there is a finite set of operators which is defined. Some of them are unary, some of them are binary, some of them are ternary also. Can you name a ternary operator?
Addition.
Hmm?
Addition plus.
Which one?
Plus addition.
Addition? No, ternary operator. Three operands. It
Question
takes
mark
three
and colon.
operands.
Question mark and colon.
Question mark, colon. Okay, question mark and then colon. This one. So the thing is, so any operators, now you say that you can count maybe the Balaguru Swami book or many other books like Kanitkar book. At the end of the book, you will find there's a list of operators, right? And you know that who is ternary, who is unary, and who is binary, and all this. So the thing is, any operator you pick up, you say that I must be able to overload it because the feature is provided by the compiler, right? Or by the language itself. So the point is, it is not that it is there. There are, because of some reasons we will see later on, we're talking about function overload, I mean operator overloading, that some of the operators are not overloaded, right? Because of ambiguity. We'll see why. But you can say that majority of the operators are allowed to be overloaded. For whom? Now these operators are already overloaded with respect to what? With respect to the inbuilt data types, right? Just now you mentioned, you saw this. So you see the plus is already overburdened. It is already overloaded because it can work, it can add two integers, it can add two floats. But when you say it's operator overloading, you mean that these operators, which already can perform in I mean, they can have in a overloaded fashion, they can perform with inbuilt data types, you can extend the idea to make them overload or make them function differently for any user defined data types also, like matrix, like complex class, like stack, or whatever. Okay, so this is what operator overloading means. But definitely there is a restriction, we'll see later, that some of the operators are not allowed to be overloaded. But the point is, a binary operator remains binary. If it is a binary operator, you cannot use it as a unary form. So its arity, its precedence, everything remains unchanged, but you can assign a different meaning or responsibility to it. Now, before we uh, just get into the other topic, can anybody tell me that how it is internally managed? Now the thing is, I know that I am happy that this is okay. I am happy that this is where it is gone. Say this. If I get into the same matrix, so matrix I write matrix M1, M2, M3. Now I would like to have, so maybe this is the end of the class definition, right? Now here within the main, can you see this? Within the main, I am declaring three objects of matrix M1, M2, M3, and I would like to have something like this: M1 equals to M2 plus M3. Now what they contain I don't care about right now, but I want to have this kind of syntax. So what do you think the compiler should do, or what you are supposed to do to support this operator overloading? Or whenever the compiler scans through this particular or parses through this particular statement, what changes the compiler makes? Are you aware of it? Do you, anybody of you know? Those who have worked in Java or maybe C++? I'm talking about the internals, what the compiler does. Like the previous one, in case of function overloading, you just now found what the compiler does. Here what it does?
So checks the parameters.
Yeah, it basically
Uses
decorates. We
decorators.
can say decorates, or it modifies the function name, and by padding the the data types so that they becomes unique. That is what it does. It's some kind of convention can be placed. But here what it does, what kind of translation takes place to this statement by a C++ compiler? Because you want something, uh, you want some kind of abstraction, but to get the abstraction done, some uh, burden need to be taken by somebody, right? So the compiler takes the burden. So what it does, any idea what kind of translation takes place?
So
Have you heard
maybe
about operator function?
the objects are identified by their type of classes assigned.
No, that is fine, but have you heard of operator function? Okay, let us not get into the much details, but it is something like this. It gets translated to this, right? So this, whatever you see is this one, but when it gets compiled, it gets translated. So what it means, you see, this is an object, and this is what is this? This is a dot operator. So dot operator means, using the dot operator in the structure, in the C structure also we have used dot operator, right, to refer to a particular member of that structure. Can you recall, all of you?
Yes, sir.
Yes,
Yes,
sir.
sir.
So the same dot operator is used here. What it says, this M2 is an object of matrix class. So this M2 invokes, what is this? Operator plus, and then this M3 is passed as an argument. So this operator plus is basically a operator function. It's a kind of special function. Okay. So what this means, this gets translated to this. So what it means, M2, the first argument, to be specific, the first object argument, the first object invokes this special operator function and passes a second argument, this argument of this binary operator into it. Okay, and then so this operator plus is a function basically. So where do you think this operator function should be defined? Who should define and who should take care of this? As like that sum or whatever. So this operator plus should be placed where? Where it should be placed?
Sir, in the main.
So this function, the body of this function must be somewhere defined within the class, right? In the class definition, it must come. Are you getting my point?
Yes, sir.
Yes, sir.
Or in other words, again, let me tell you, don't be, I mean, those who are the first timer, trying to learn the C++ language. So these each and every of these concepts will be elaborated in much details. Just I would like to have a provide you the flavor because I am focusing on the features, not the syntax and the other detailed technical issues. But it's just a point that I thought that I should be mentioning so that you know that because C++, Java, for long, I mean, these days, even from class 7, 8, people are learning, the students are learning, but the focus is something different. They learn to write algorithms or those small loops and all. Some of you, go a bit ahead of that and develop some kind of applications, but we probably don't bother about the compilation, how it takes care of, how it's like in a Python. Do you need to specify a data type if you would like to store some values in an array in
No.
Python?
No,
No.
sir.
No, sir.
No, sir.
I mean, those who know Python. So now, can you imagine that here in C, we have to specify it's an integer, it's a long int, it's a long int like that. You have to be so specific, and you have to keep big, so specify the size of the array because everybody knows C. And C++, you are trying to make a bit things a bit more abstract. You are hiding everything there and you are hiding something there, and in Python it goes in another extreme, so you don't have to specify the type of the data. You just write the name of the array and use initialize array, that's all. So who is going to take care of it? Definitely the compiler, the runtime environment in the backend need to take care of this. So nothing comes with the expense of some additional overhead, but the overhead, and that's why C++ is faster because you are more explicit. But when you try to try to have more abstraction, probably you slow down the process. So that's why, that is one reason why you may not be willing to write Python codes for all kinds of computational scenarios. But again, so the point is this abstraction. So this is abstraction, right? You are trying to overload, and it appears that the same plus binary operator works for matrix, for complex class also. But the compiler, if I know the compiler translates it like this, so to support this we have to basically write a function called operator plus here. Okay, so we have to basically write here okay, so here something like operator plus. So this means this is a function name, so this operator plus. If you are trying to overload the minus, then it is operator minus. So operator is a kind of keyword, and you have to specify that particular function name. So how many arguments it accepts? One argument. So it's like matrix X. What it returns? Again a matrix type argument. So this it returns, and then you write the details of it. Basically two for loops and all. So got the point how it is done? So what we see, it is very easy, but actually as a programmer you are doing the things, you are making things easy for whoever is using your class. So if you are the class designer, if you have made this provision, if I am the user of the class, I can write smart and compact codes, right? So this is what we mean as function overloading and operator overloading.
Excuse me, sir.
Hello?
Sir, is this not becoming same as that of the sum function?
Same as that of?
Sum function, sum.
Yes. See, same means sum, you have written your own name, you have given your own function name. But here, the function name, definitely the point is you have to write that specific function here within the class body, within the class definition. But again, I mean, if you think of like the sum also, the internals, the body of the function is the same, but the function name is different. And because of the difference of the function name, you have got much more compact calls, like you can write m1 plus m2. But as you mean that if I am writing if I come here, so whatever is written here and whatever is written here it's all the same. Yeah, that's true, because that you actually want to have them the same way, right? Do you want that m1 m2 or m2 plus m3 will be added? Do you expect this sum and this operator plus will return some different results? You don't, right?
Yes, sir.
Hello?
Yes, sir.
So you actually write the same thing, but then because of the difference, so here you are giving a different name which is meaningful and which is not so matrix, sounds matrix like. It's a sum, that's all. But here it is operator plus, and you can just use a symbol for this.
Okay, sir. Thank you, sir.
Okay, so that is how the function overloading
Excuse
and
me, sir.
operator overloading. I don't know why it is getting removed every time. So these are, so this is another way of, so operator overloading you can call it as, this also is an example of writing polymorphic codes, right? So it's a polymorphism, it's a operator symbol
Excuse me, sir.
polymorphism, it's a function name polymorphism. Do you know other kind of polymorphism that exists in the object oriented languages? Any other examples of polymorphism? I'm asking to those who have who are already familiar and aware of writing big codes in
So
Java.
we have so we
Yes,
can have a runtime sort of runtime polymorphism,
yes.
which
What
is
is that?
also known as method overriding.
Hmm. Now, runtime polymorphism. Yeah. Can you
It
specify
is
the
a
name?
method overriding.
Mm, okay. Any other names, generic names that you find? Have you heard about virtual functions?
Virtual functions.
Have you heard about virtual
Yes, sir.
functions? Okay. Again, those who are not aware of, just forget about it. You will at the end of the course you will all be aware of it, and you know not only the names but also how it implements and what are the internal details, how the compiler handles it. So this is not the case, but again those who know it already, they can relate it. Uh,
Sir, templates can be a part of
yes, template
type.
also is a kind of polymorphism.
Yes.
So what is template is, you see, I mean you can understand, everybody can understand, those who even know C also. Say if I write, if I ask you write a stack code, write a code for stack, I don't mention anything. So what kind of array you should define? I don't mention anything, but I say that write a code for implementing stack. What you would have
So
done?
1D array. So the 1D array.
1D array, but I am asking about the type of the array. What type of array you would have declared?
Use the template.
Null.
Hmm?
An empty array. An empty array.
No, no. Empty means, I mean, I ask you to write the code. So maybe without guessing anything, if I start giving an example, I said, okay, let me take its integer array, or I mean the integer stack. So when I give a, when I say you should implement a stack, probably you tend to, if I don't specify anything, you implement a integer stack, say for example. But then you wrote an integer stack. I told you, okay, no, I want a floating point stack. So then what you do? See, the data structure is the same, right? You are still defining a stack. You're writing the code for stack, and so it's like int a10, int top, and then you have the push, then you have the pop, all these things, right? So push means you have to write int say a, which you are actually want to pop, push. Pop actually returns int like this. So this works. So now when you bring it to me, I say that no, I want a floating point stack. So will the same code work where you need to make changes?
No, sir.
So we need to change the type of.
Where you want to make changes? You want to make it float, you want to make it float, you want to make it float, right?
We can use
Again after 1 week,
template.
I tell you that okay, no, I want a character stack, just bring me a character stack. So then again you write another piece of code. See the point, everything is same, almost everything is same, you just keep on changing the data types, because what I mean to say is the data structure is the same, the methods that you apply on the data structure are the same, the logic is the same, the only thing is the contents, the elements of the data structure, the type gets changed, right? So why should you should start shouting that why should I write every time the same logic, the same piece of code, just changing those into float to character, this what's happening? So then C++ helps you, or any object oriented language helps you, says that okay, you just cool down. So there is a way of doing things. You just, instead of writing here intent, so make it generic. So don't specify anything, let it be like this. T, what is T? T is a symbol, that's all. And once it is T, and you have written sometime like a stack class like this, so you have the facility, like you have to write stack int, and you have to write a, so this becomes an integer stack, like the stack float, it's a floating point stack. Stack character, you have got a character stack, right? Like this. Okay, again, I mean, there is some template, this T and all this, it's all there. But the thing is, this is, so even the C programmers, can you see the facility? So you just have defined the data structure stack. By encapsulation, you have included the push and the pop along with the character, along with the variables, right? But not only that, wherever you found that the data type might be different in different cases, you have made it generic TTT like this. And once I ask you just provide me an integer stack, you instantiate it as an integer stack, float stack, character stack like this. So this is also a kind of polymorph. So this particular definition is polymorphic, right? This definition of the stack data structure is polymorphic. It can act as a integer stack definition. It can be used as a floating point stack definition like this. So that's why we come to this point that, so this part we have already explained earlier in the last class, right? Now here, this polymorphism is the ability to assign different meaning to a particular symbol, operator, method, or class, and polymorphism enables one common interface for many implementations. I think you can relate to these words by this time, right? It provides one common interface for many varying implementations and for objects to act differently under different circumstances or context, whatever you say. And static polymorphism will differentiate it later on. You'll be able to appreciate the difference. But right now, this function overloading, operator overloading, templates, these are static compile time polymorphism. So during compilation, this polymorphism, so who is taking the burden? So the compiler takes the burden of implementing the polymorphism, I mean the polymorphic nature, by changing the function names, by changing the those operator calls, also by making some changes in the when you define a template. So this previous example, this is, I don't know why it is, so it automatically became volatile. Every time I write, I switch back to it goes off. I don't know how it is happening. Anyway,
Hello,
so
sir.
this is,
Hello,
hello,
sir.
hello.
Sir, is type casting of a pointer is some kind of polymorphism?
Passing of a pointer, passing of void pointer, you can say, but yeah, the thing is, you can put it in another way, like if you want to implement polymorphic codes, probably you rely on void pointers, right? Because void is a basically generic type. Now void, you can typecast it to integer, to typecast to float, and all this. So using void pointers, you probably achieve polymorphism rather than you say that void pointer is a polymorphism. So it's a tool that you use to achieve polymorphism, to write polymorphic codes. Is that fine?
Yes, sir. Okay, sir.
We will see it later on because there are many questions. I'm trying to put everything here so that you, I mean, for others also, they get motivated. Okay, why should we study C++ or object-oriented programming, and what are the advantages? So you will be able to appreciate the advantages, and you know that we have to use it in our codes. Okay. So this dynamic or runtime polymorphism, one is virtual function that we just now mentioned, and another is dynamic cast. Is there anybody who has used dynamic casting, RTTI? Typecasting. So in C we have used typecasting. So this is more of a static casting, and we can go for dynamic casting also. So we'll see it later. Anybody who is aware of the term dynamic casting? Downcasting, dynamic casting.
Heard it before but never used it.
Hello? Louder, a bit louder.
So heard the term but never really
Yes,
used
so
it.
these are there. I mean, we'll be encountering these terms later on. Okay, so that's it's a whole bunch of things that you'll be able to learn if you know C++. So to just sum it up, object-oriented design advantages: the real-world abstraction can be, so it's a real world, it can be modeled in a much better way. The real world encapsulation's ability to bind data and method together to obtain more cohesive modules. This is one advantage. Hiding, the ability to hide private class members, both members, when I say member, it can be data or methods both, so that they cannot be accessed from other outside. So you have got more importance and more control over data. inheritance, it increases reusability, because through the inheritance, if B is derived, or I mean B is A, that means A is already there and you are trying to define B, so you can use the definition of A for definition of B. So you don't have to write B from the scratch. You just say that what are the additions that I need to make. Okay, so the definition can be reused, so that is increases reusability, the inheritance. And here during inheritance, or this is called the base class, this is called a derived class. Okay, this is the terminology that we use. Polymorphism, we just now uh, talked a lot about it. So this is programmer friendly. This, if I use multiple types of polymorphism, programmer friendly, and it increases the code readability. And there are other advantages also, and easy to maintain. And in fact, those things like in the Python, there are many tricks. I mean, it's not tricks, but there are many magical things that happen. Like you don't have to define the data type, and it works. So for a C programmer who know the low level basics, so he will be quite surprised at how it happens, how the compiler and the language handles all these details, because it's not that the machine that we are using got changed. So everything is the same, and how the language becomes so intelligent that even if you don't specify the data type, it is storing whatever comes, it stores like this. So to know this, you have to know polymorphism and how it is working. And this is easy to maintain because you are dealing with more cohesive modules. So any kind of changes that you make, you can make sure that I am changing the definition and the rest will be intact. So because the coupling is less now. Okay, so these are the advantages. So can you draw the analogy here? What will be the analogous terms? Okay, so when is the next class that you are having?
Or in 15 minutes, sir.
Hello?
Sir, it starts in 15 minutes only, sir. We have to come 5 minutes early. We've been told to join the class 5 minutes early.
So when it starts? 4:30?
Sir, it should start at 4:30, but we've been told to join early because it's our first class, sir.
So
Then
may
10
I be
minutes
able to
early.
take another 7-8 minutes?
Sir,
Now it is
prob-
4:10, or I
sir,
need to stop it right now.
sir, probably we can do with
Okay, another
7.
5 minutes.
Yes, sir. Yes, sir.
Just alert me. Okay, within another 5 minutes. See, so can you just quickly draw the analogy? Data type in procedure-oriented programming, what do we call it as?
Class.
Class.
Data type,
Sir,
class, right?
Class.
Variable,
Class.
variable,
Object.
object,
object.
function,
Object.
procedure, subroutine.
Method.
Method.
Methods.
So those who are not aware, you should know that you should keep talking about methods. Okay, more than. And function call. Function call, it's something a strange term. It's called message passing, right? So you are invoking the method defined in a class. We call it as through the object instance of that. It's called using the dot operator that we just now did. So it is called message passing kind of. And header file. So in the procedure oriented programming, if you define a header file, if you try to link a header file, so in the header file, what it contains, it's a library of pre-written functions and procedures. What do we expect here in object oriented programming? A library file will include what? What it will include?
Different
Classes.
classes. Different classes, sir.
Different classes.
So
Classes and
pre-written class
methods.
definitions, you can expect some pre-written class definitions. That is
Sir, a
possible. What else
package.
you can expect? You can expect simple like library functions also, because in C++ it is not like Java that everything should be, each and everything should be object oriented. It is kind of hybrid. It supports procedure design also, it supports object oriented design also parallelly. But the point is here, as you can see, so these are all the same, and in object oriented approach, abstract data type, or you can say it's a class. But what I'm trying to highlight this point. Can you see this? Pre-declared objects. So it is not only that you are when you in the header files in C++, you are having predefined classes, but you also have predefined objects. The instance of the classes are also sometimes predefined. So if you just use it, you can just start using it without explicitly declaring it. We'll see that while writing the first C code, what are such objects, predefined objects. Got my point?
Yes, sir.
Have you got the point? It's not only a class
Yes.
library, sometimes it may be considered to be that few objects are also defined for your convenience. So this is what is the language abstraction is. In the assembly level, you write probably to store 12, 5 and say 12 or say 10, to store 12, 5 and 10 in some memory location. You write that 12 stored in register B, register C. So in 3 registers, CPU registers you write. If you would like to write it in procedure oriented programming like C, you write here integer X, these things like this. And in an object oriented language like Python, you can just write this. Is that allowed? The last one, this one?
Yes, sir.
Yes. Yes, sir.
And in
Yes.
fact, there is even something more surprising, at least for many of us who are not very much familiar with Python coding, like this. What does it mean? So it's a kind of hybrid. So even if you are not putting, homogeneous kind of elements, forget about declaring what type X is, forget about declaring the size of it, forget about allocating the space for it. You just write this and the whole thing is handled internally. So it's something quite a magic, those who are here, okay, for them, and for them it is really a high level of abstraction which is supported and which is possible if you write object oriented codes by implementing polymorphism and all these details, right? I think it's almost the time. So this is object based and object oriented language, and this C++ is basically an object oriented language, and it includes all the object based language features like class definition, object definition, access specifiers, automatic, this is garbage collection, and operator overloading. So the thing is, the object based languages like Ada and Modula, it was invented in 1983. They are object based languages, and these object oriented languages includes all these features, but this inheritance, function overloading, virtual function late binding, and all this. So C++, Java, Python, and C hash, these are all object oriented language, and in C++ we'll be learning all these in details, the syntax, the underlying philosophy, and what are the challenges and how the compiler handles it. Okay, so this is the end of the class. This is the reason why we still stick to C++, because as you can see that it is still in the 5th position among the different set of languages in January 2021. So this has been, I just copied today morning, and this is the long-term history, as you can see here, from 1985, because it was first published in 1985. It was in 12th position, and then it came in the first position during our college days, but then again it slipped back because of Python, Java got into the scenario in late 90s, and then gradually now, but still it is holding its position in the 3rd or 4th place in 2020, right? So you can still see that how consistent it is, and there are lots of softwares which are still in C++ or C, and C, you can see that still it is moved in too. So the C and C++ can still be a something that the recruiters look for. Okay, that's the, let me switch off the, stop the recording.